Jai Hind students. So we are now studying about electronic configuration. What do you mean by electronic configuration? What is the definition for electronic configuration? Distribution of electrons in different subshell is known as electronic configuration. What is electronic configuration? Distribution of electrons in different subshell is known as electronic configuration. For example, you all know sodium. Am I correct? Sodium. Sodium means, what about the atomic number? Sodium atomic number 11. So atomic number 11 means it consists of 11 protons and it consists of 11 electrons. The proton, there is 11 proton is present inside the nucleus. But these electrons are revolving around the nucleus in different orbit or different shell. You may study in your lower class that these 11 electrons are distributed in such a manner that the first shell contains 2 electrons. The second shell contains 8 electrons. And the last shell, the third shell contains 1 electron. This is the distribution of electrons in different shells. But now we are going to study about electronic configuration. Electronic configuration means distribution of electrons in different subshell. Each shell having subshell. So what are these subshell? S, P, D, F. These are the common subshell. Other than this F, G, H, I, like the different subshells are there. Let us discuss what about these subshell. So we studied the first shell is called K shell. The K shell is otherwise called first energy level. That first energy level having only one subshell. That means that subshell is called S. The second energy level are otherwise called L shell. So L shell is otherwise called second energy level, which having 2 subshell. What are they? S, P. To differentiate this S and this S, what we are doing? We are placing this as 1s. This is called 2s, 2p. 1s means this 1 indicate this is the s orbital or s subshell of first energy level. 2s, 2p means it is the s orbital or s subshell of second energy level and p orbital of second energy level. The third energy level, that is otherwise called M shell, contain S, P, D. There are 3 subshells are present for the third energy level. So that is labeled as 3S, 3P, 3D. So what about the fourth energy level? M shell. It contains 4S, 4P, 4D as well as 4F. These are the subshells of fourth energy level. So what about the subshells of fifth energy level? M, N, O shell. So fifth energy level having 5S, 5P, 5D, 5F. Other than this 5F, 5H is also humming, but we don't want that. So what about the subshell sub 6 Sixth energy level 6s, 6p, 6d, 6f. So other than this 6h, 6I is coming. So like that, each energy level or each shell having different subshell. How the electrons are entering inside the subshell, that is based on energy. The first, the electron enters the subshell which possesses lower energy. That is, first S having low energy than that of 2s. 2s having low energy than that of 2p. 2p having low energy than that of 3s. This we can understand from Abba principle, or principle called Abba principle. That principle you are going to study in chapter 2. So, based on Abba principle, electrons are entering inside the subshell based on energy. What Abba principle said? First 1s orbital will fill, then 2s orbital will fill, then 2p orbital will fill. After 2p, 3s orbital will fill. After 3p, 3p orbital will fill. After 3p, 4s orbital will fill. After 4s, 3d orbital will fill. After 3d, 4p will fill. After 4p, 5s will fill. Then 4d will fill. 5p will fill. 6s will fill. It goes like this. Based on energy. Based on this, we are going to write the electronic configuration of sodium. Sodium atomic number 11. We know sodium consists of 11 electrons. How these electrons are distributed? In the 1s orbital. S can accommodate only 2 electrons. 2 electrons of sodium enters 1s orbital. Remaining how many electrons are there? Remaining how many electrons are there? 9 electrons are there. So among the 9 electrons, the second S, 2s orbital, S can accommodate maximum 2 electrons. So 2 more will be entering here. So 2 plus 2, 4 electrons over. Remaining how many electrons are present? 11 minus 4, that is 7 more electrons are present. Where the 7 more electrons will go? So this we studied. The second energy level having 2 subshell S and P, that is 2p orbital. P subshell can accommodate to the maximum of 6 electrons. Now how many electrons over? 6 plus 2, 8 plus 2, 10 electrons over. Remaining only 1 electron. We studied after completing 2p orbital, the next shell is 3s orbital. 3s can accommodate maximum of 2 electrons. But how many electrons we are having now? Only 1 electron. So this is the electronic configuration of sodium. So what about the electronic configuration of lithium? Atomic number 3. So only 3 electrons are present. Where the electrons will go? 1s, that is the lowest energy subshell, can accommodate maximum 2 electrons. Remaining how many electrons? Only 1 electron. Where it will go? It will go to 2s orbital. Only 1 electron. This is the electronic configuration of lithium. So what about the electronic configuration of fluorine? Atomic number 9. 1s2. That is, S can accommodate 2 electron. Then 2s can accommodate 2 electron. 2 plus 2, 4 electron over. 5 more electrons are remaining. So next to 2s, 2p orbital will come. The 2p can accommodate maximum 6 electrons, but we are having only 5 electrons, so 5 electrons will be there. So this is the electronic configuration of fluorine. So what about the electronic configuration of nitrogen? So nitrogen, atomic number, tell me the atomic number, 7. So how can you write? First, 1s orbital can accommodate 2 electrons. Second energy level, that is 2s, can accommodate 2 electrons. 2 plus 2, 4 electrons over. Total is only 7 electrons. That is 3 more electrons are remaining. Where they will go? They will go to 2p3. How can you write the electronic configuration of potassium? Let's see. Atomic number 19. So atomic number 19 means 19 electrons are present. So 1s can accommodate only 2 electrons. 2s can accommodate 2 electrons. Then after 2s, 2p will come, which can accommodate 6 electrons. After 2p, which will going to fill 3s orbital. So 3s can accommodate 2 electrons. After 3s, 3p orbital will coming. That it can accommodate 6 electrons. Totally how many electrons over? 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18 electrons over. After completing 3p orbital, the electron goes to orbital. How many electrons are remaining? Only 1 electron is remaining. So it will go for us. So this is the electronic configuration of potassium. This can be simplified. Just to see, if you count 2 plus 2, 4, 4 plus 6, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18. So this much comes 18. 18 means this is the atomic number of argon. So argon is an inert gas, noble gas. Inert gases possess stable electronic configuration. So there is no change. So this can be written as, instead of writing this much, we can simply put argon in square bracket. If you are putting argon in square bracket, that indicate this much. That is, that indicate 18 electrons. That argon in square bracket indicate 1s2, 2s2, 2p6, 3s2, 3p6. So how can you write? 4s1. Is it clear? How can you write the electronic configuration of chlorine? Chlorine, what is the atomic number? 17. 1s2, 2s2, 2p6, 3s2, 3p. Count the number of electrons. 2 plus 6, 8. 8 plus 2, 10. 10 plus 2, 12 over. Totally 17 electrons. 3p can accommodate maximum of 6 electrons. But we are having only 5 electrons. So 5 will go. This can also be simplified. How can you simplify? 2 plus 2, 4. 4 plus 6, 10. 10 means it is the atomic number of neon. We can write neon in square bracket. If you are putting neon in square bracket, that indicates 10 electron. So after neon, what are coming? 3s2, 3p, 5. What about the electronic configuration of scantium? Atomic number 21. How can you write it? 1s2, 2s2, 2p6, 3s2, 3p6. How many electrons over? 6 plus 2, 8 plus 6, 8 plus 6, 14 plus 2, 16 plus 2, 18. So after 3p, as per our above principle we studied, so after 3p, which will complete? 4s will complete. So s can accommodate how many electrons? 2 electrons. But third energy level, this third energy level having s orbital, p orbital as well as 3d orbital. So after completing 4s electron, the remaining electron goes to 3d level. 3d level is present just inside 4s level. Because listen here, first energy level, second energy level, third energy level, fourth energy level. First energy level having only one subshell. Second energy level having S and P. Third energy level having S, P, D. Fourth energy level having S, P, D, F. So after completing 3p, it will goes to 4s. After completing 4s, it will comes to inner 3d orbital. Be careful about this. So what happened? So how many electrons now over? 3p up to 3p, 18 electrons over. When it comes to 4s to 20 electrons over. What about the electronic configuration? Atomic number of scantium? 21. How many electrons remaining? Only one electron. Where it will goes? It will goes to 3d1. This is the electronic configuration of scantium. So in scantium, where the last electron goes, it goes to d orbital. Where the d orbital, it is present just inside from outside. The outer shell is called ultimate shell or valence shell. The shell which is present just inside the outer shell is called penultimate shell. So the shell which is present just inside penultimate shell is called anti-penultimate shell. Don't forget these words. Ultimate shell or valence shell, penultimate shell. The shell which is present inside penultimate shell is called anti-penultimate shell. So listen here. This is the electronic configuration of scantium. How can you simplify this? Instead of writing this much, we can write, simply put organ in square bracket. If you are putting organ in square bracket, how many electrons over? 18 electrons over. So after organ which will come? 3d1, 4s2. How can you write the electronic configuration of manganese? So manganese atomic number 25. If you write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, after completing 3p6, 4s2 will come. After completing 4s, 3d will come. So how many electrons over? Up to 4s2, 20 electrons over. Remaining how many? 5 electrons. Where the 5 electrons? Here goes to 3d orbital. This how can you write in simple manner? So instead of writing this much, we can write organ in square bracket. So then we have to write 3d5, 4s2. So if you go through our examples, in some of the cases, the last electron goes to s orbital. In some of the cases, the last electron goes to p orbital. So in this case, the last electron goes to, where it goes? It goes to d orbital. So based on the valence electron means last electron. So where it goes, in which subshell it goes, we are having 4 groups of elements in periodic table. What are the 4 groups? S block elements, P block elements, D block elements and F block elements. We will discuss about S block, P block, D block and F block elements in our next video.